What is going on, guys? What I have here is a 2000 Honda Odyssey with a 3.5 liter engine, and it's my father's car. What we have to do in this video is find out why the battery drains if it does not get started for a couple of days. So haven't had any time to really look at it. I know there's a parasitic draw for sure. So now in today's video, I'm going to show you how we're going to go about tackling that. And maybe this video might help some of you guys if you have an issue similar to this one. So let's get started. If you got an issue with a parasitic draw, the first thing you want to check before starting anything is the battery voltage. You want to have the battery charged up to about 12.5, 12.6. This one is at 12.3, which is going to be okay for this test that I'm going to be doing. I did start the car earlier. I let it idle for a little bit. So 12.3, as long as the battery's not discharged to about 11.5, that might affect the values, the readings that we get. But I'm happy with 12.3, so let's get started. There's a few ways we can check for a parasitic draw. One of the ways is to use our meter. Before we actually do that though, we need to get the car ready for the parasitic draw test. And what that means is we got to open all the doors, the trunk, and lock all of the latches. So I'm going to show you that in a little bit. Another way we can check for this is by using a amp meter. This just hooks up around the cable and it will read the amperage draw that's going through that cable. You have to zero them out because they do tend to drift over time. So you could use a combination of both if you wanted to be sure. Now on this car, the draw is pretty significant for the fact that it goes down after a couple of days. The other test you could use is an actual oscilloscope with an amp clamp, which sort of does the same job as this, but you get to view it as a graphing meter type of thing instead of, just numbers on the screen, which, that has its benefits as well. If it's a parasitic draw that only happens after some time and it's a very random intermittent parasitic draw, which does happen. So now let's get started by putting our car into service mode, which means we got to open all the doors, the trunk, and lock all of the latches. On this particular vehicle, the sensor is going to be right here, so we can hear that beeping going on over there in the cluster. If we press this, the beeping goes away, so it thinks that the door is closed. We're going to just put something here, maybe a piece of tape or something, keep this latch closed. And there you go. I just put the tape just so we can hold this sensor here pushed in, and that's going to allow the car to go to sleep. Now let's do this to all of the doors. So the car should be ready to go. We can just do a very quick test with this tool here. We'll turn it on. Not sure if you guys can see that or not. And right now it's in auto. We want to press it until it's on the amp spot right over here in the corner, and if you hold this, it's going to zero it out. And now we can just hook this up around the cable. I'm going to hook it up around both cables here. That's the reading that we get, 0.19, so 0.17 amps, 0.17 amps, or 170 milliamps. So a good rule of thumb, we need to see about 30 milliamps or 0.03. So definitely right now it's at 1614. Still, it's about 3 times as much as it should be, and I really hope you guys can see this. The glare is kind of bad. So right there, you should be able to see that 0.14. And on most vehicles, you gotta let it sit for anywhere between 20, 30, 40 minutes. Most older vehicles, they should turn off within 5 minutes. The modules should all go to sleep. The test I'm doing right now is actually with the car unlocked. You can do it with the car locked and with the car unlocked. The parasitic draw for this specific vehicle happens whether the car is locked or unlocked. There are some vehicles that the parasitic draw may only happen either when the car is locked, or may only happen when the car is unlocked. So it's a good thing to know good thing to pay attention to, and it's worth it to do the steps in both ways. I got the alligator clips here. We're gonna hook up these to the banana jacks. Right now I still have it on volts. I am going to swap the red lead to where it says amperage. Alright, and we can turn this to amperage and we can read what we have. Now we gotta let the car go to sleep because when you do that, this supplies a little bit of current to the vehicle so the modules turn on. So we gotta let it go to sleep, you know, give it a little bit, and we can read either, you know, milliamps, or it should be 0.03. That's what we should see. Okay, and along with that, let's zero this out one more time, and we can also hook this up around the battery. This is reading 0.14. This is reading 0.2. So 200 milliamps, and that one is reading 120 milliamps. That's why I said, you know, you could use both. That's why I said, you know, it's a good idea to use both, but that other one is just very easy to use. Hook it up, you know, takes a couple of seconds. So I'm going to put you guys over here. So now let's get started. What we want to do is locate the fuse boxes that this car has. We got a big one right over here. We have some fuses over there, only a couple. But let's start with this one here. What you want to do is go through all of them. You could use the meter. I have another tool also you can use. It doesn't really matter, but you can use the regular meter. You just got to go across the fuses and see what type of draw you have and where that draw is. Alright, so let's get started. So this is the tool I'm going to be using. It's called the amp hound, and what this does is you just go across the fuse. Once you see some sort of draw, you can then pick what type of fuse you have, and this will do the calculation for you. So it reads voltage drop across the fuse, and it turns that into a calculation if there is a voltage drop. So if all the systems are working properly, we should not see a voltage drop across anything. But we definitely know we have something because right over there we got 200 milliamps still. Okay, so it's very simple. You turn it on, you go across the fuse, and you'll hear that beep. That beep, and it will give you 000. It will give you some numbers. If you have a voltage drop, it will have a different sound, and also you'll see once you pick the type of fuse you have, you'll see what the amperage draw of that circuit is. Okay, go across all of the fuses. It's not important to pick right now what size fuse you have. You just want to go through all of them, and once you find an affected fuse, if there is one over here, then we can move these values around. Okay, we checked all of the small fuses. There's nothing that I see on any of the small fuses. We also have these types of fuses that have the covers on them. You can either disconnect them and do them that way. The problem with doing it that way is you run the risk of waking a module up. On an older car, maybe not as big of a deal, but on a newer car, definitely no. It will wake, there's so many modules, it will wake something up. Now you gotta wait 10, 15, 20 minutes again for it to power down. So we can just pop this cover off on them and we can start testing that way. So you just want to get a pick. You want to go underneath. There's tabs on each side, and you want to pry this cover off, and it comes off like that. And then you can just go across the fuse and test it that way. So let's get this up here. Hopefully this will be in the shot as well. I'll go from the back here, and you heard that sound. So it's not, so that's a good one. This is some draw on this circuit. Now we can pick what this is. So this is a 40 amp fuse. So we pick maxi and let's go to 40 amps. So it's a maxi fuse, 40 amps, and this will do the calculation. Hold that. So after you pick 40 amps, hold this down until you see that. You go across the circuit and we can see this is about an 80 milliamp draw, 0.08. So definitely high. If we unplug this, I'm pretty comfortable with these readings. If I plug this fuse in, our draw will come back. So let's see what happens. Let's give it some time. It's been about 5 minutes and our readings are the same. We are at 200 milliamps of draw. So this is definitely our draw right here. Now let's find out what this fuse does. Okay guys, so I was able to find out the fuse box here. This is our fuse right here, number 54. That's there. And what that one controls, let me scroll down here. Fuse 54 says backup accessories, and it controls fuses 9, 10, 11, 12, and 13 in passengers, under dash, fuse, and relay box. Okay, so let's go 9 through 13, passengers, under dash, fuse. So let's go to that. This is passengers, under dash, fuse, and relay box. Let's zoom into this, and we need to go 9 is accessory socket, audio unit, front and rear accessory power sockets, navigation display unit, blah blah blah. 10, small light, license light, so the rear license plate lights. If those short, that could definitely do it. 11, interior light radio, cargo area light, left and right, front, rear individual map lights. And we got power door locks, clock backup, and that's it. So 9 through 13. That's what we need to go and test next, and that will sort of pinpoint our issue. So we're gonna go there, we're gonna check 9, 10, 11, 12, and 13, see which ones of these is staying on. These are the fuses right over here that we have. Okay, so number 1 starts here. That 1, 2, 3, 4, 5, 6, 7, 8. So we got 9, 10, 11, 12, 13. This is what we need to focus for right here, from the blue to the first burgundy fuse. Okay, so let's use our amp hound. We'll get this turned on. Like I said, it does not matter what fuse you're in or what type of setting you're in. Okay, that's 0. That's 0. Right here, this is our affected circuit. Alright, let's see this one. Okay, so we got 2 fuses here. This one. Hold on. We want to make sure, so let's go over them one more time. Okay, this one here, it's a 10 amp fuse. So let's switch this to the standard fuse. And it's a 10 amp fuse, and let's see what the draw is. Okay, we got 0.02 here. And then next, this one was okay. And then we have a 7.5. And this one has 27. The draw on this one is 27. So let's find out what this one is. So fuse 11, interior light. It says cargo area light, left and right front and rear individual map lights, front individual map light, and navigation display unit and navigation unit. This one does not have a navigation unit, so we don't need to worry about that. But we need to look at all of these lights. Now, if any of the lights were staying on, you know, we should be able to see the bulb unless the bulb is burnt. Alright, and that 13 is clock backup. So climate control unit, EXL, clock, except navigation, which we don't have navigation, door multiplex control unit, high possibility that's an issue, driver's multiplex control unit, we got gauge assembly, heater control panel for LX, keyless receiver unit, EXL, left and right power sliding door control units, passengers multiplex control unit, PCM. So that gives us a little bit of an idea of what we need to tackle. I think the easiest ones to go after would be all the lights, the interior lights, and we just need to see if any of them are staying on. So what we have to do now is actually start disconnecting the affected circuits. You know, disconnect this one in the back, see if the draw goes away. If it doesn't, go through the rest of the other lights. If the draw does not go away still, then we move on to the other fuse. But this here should definitely have some sort of amperage draw. Although it was pretty small on the thing, it was still significant enough for it to be picked up. I think it was about 30 milliamps, which you know, that's what the car should pull in general. A good car should pull, so it's definitely high. This here, it's kind of almost broken, so let me get this off and I'll come back with you guys. I unplugged this whole module over here, and let's see if our parasitic draw changed at all. I'm in the front here, and the parasitic draw is the same. It did not change at all, and we pretty much checked all the lights in there. Left and right front, rear individual map lights, front individual map light, so that's all of them. I'm gonna check the fuse here one more time. I still have that disconnected, so let's see what we get. It was the red one. So from this one we're getting 20 milliamp draw, and that is number 13. Let me go back. So number 10 no longer has a draw. So after disconnecting this one, that one no longer has a draw. And it could be either the socket here or the actual module unit. I have seen that. The lights seem good. I'm gonna plug it back in, see if our draw comes back for this circuit. So for this one, there's no longer a parasitic draw. It picks it up at 10 milliamps. So what I can do is either just disconnect that, but I'm not too worried about that one. That one will not cause the car, 10 milliamps will not cause the car to go dead overnight or after a couple days. So let's focus on this other one here, because this one does affect a little bit more stuff. All right, let's go after that one. If I disconnect this fuse, we can go and see what our parasitic draw is. We can see our parasitic draw went down to about 6-7 milliamps. All right, so this is, our car should be good. If this fuse was not connected, the car would not go dead after a couple of days. We'll put this cover here on because I don't need that anymore, and we'll see. We got clock and backup, climate control unit, EXL, clock, except navigation, which I do have the clock, door multiplex control unit, driver's multiplex control unit, gauge assembly, heater control panel, keyless receiver unit, left and right power sliding door control units, passengers multiplex control unit. The only way to really figure out which one it is, you need to go to every single one and start disconnecting the modules to see which one it is. What I'm going to do is I'm going to check a couple of the easy things to check, which is probably, you know, the clock, in case the clock will draw that much. Highly doubt it, but I guess maybe. Gauge assembly could cause it. Heater control panel, I need to see where that is. Keyless receiver unit, that could cause it. I'm going to see which ones are easy to check. What I might do is just leave it disconnected. It is my dad's car. This car does not get driven long distances. It's only local to haul stuff. It's a van. It's got over 200,000 miles on it. Alright guys, I disconnected these things over here. I disconnected the clock. I disconnected the climate control unit. And I have my meter over there, so I'm reading that at the same time, and there's no changes so far. And even when I disconnect this here, let's see, there's still no change. Therefore, our issue is not the climate control, it's not the clock, and this is how we start ruling things out one by one. Now I just have to decide if I want to go to the rear doors or not, which that's where I think our issue is. This stuff is installed, that is installed. Our drawer is the same up there, so we can cross these out. Climate control, we can cross that out. We can cross out the clock. Driver's multiplex control unit, let's see what that is and how easy or hard that is to find. So we can see the power sliding door control unit, and then the door, driver's multiplex control unit, and driver's under dash fuse / relay box. Let's see if there's a picture for this. Okay, so it's going to be right over here on the side. So let's go to that. That should be easily accessible. Yeah, unplug that and see what happens. So this module right here, I know it's a little bit hard to see, but that module right there is our driver's multiplexer unit. And that part right there, I disconnected it. Our parasitic draw went down by about 20 milliamps, so nothing drastic. Therefore, I'm going to go directly to the rear doors and start disconnecting those and see what happens with those ones. Okay, so I got the control unit right here for the sliding door. This is the driver's side. I unplugged the connector here, and our draw still the same, 200 milliamps. So let's plug this back in. All right guys, so the issue is found. This is what we have right now. We have about 88 milliamps. Definitely not fixed. I like to see 0.30, so definitely it's not fixed, but the issue is definitely with the rear doors. Now, like I said, this car is very old. I was able to get it to that. Should last you know, 3-4 nights before the car goes dead. And this is with everything working, so the blower motor, everything should work. That's how we got to that. What I did was I just cleaned up the contacts on the door, and I was able to get it down to that. So right now we're at 150. I just opened this. Right over here, these contacts, they need to be replaced. Probably not making clean contact, and sometimes it shows the door is open even though it is not open. So to fix it, replace these contacts here. I'm not too worried about them. A bit of a cleaning and they are better now. So if I close this, and I'm closing this manually, so if you close this all the way properly, our voltage should drop. Let's give it some time. The voltage should drop to about 0.8. So we can see right there, we got about almost 100 milliamps, which is on the high side. But I hope that helped you guys into finding out the parasitic draw, the steps that you take to start tracing the parasitic draw. It is definitely time consuming depending on the issue, because you got to start disassembling some stuff here and there. So it is time consuming. Parasitic draws are can get expensive if you take it somewhere because of this, because of the time that it takes to go behind of after all of these modules. But like I said, I hope this video was helpful for you guys. I'll try to post as many how-to informational videos as I can. If you like this type of content, consider subscribing, leave a like on this video, comment down below with what you might want to see next, and I'll see you on the next one. Bye-bye.